Chapter 2
of Agriculture for Beginners.
The Soil and the Plant. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Harrison. Chapter 2 The Soil and the Plant. Section 8 Roots. You have perhaps observed the regularity of arrangement in twigs and branches of trees. Now pull up the roots of a plant as, for example, sheep sorrel, Jimson weed, or some other plant. Note the branching of the roots. In these there is no such regularity as is seen in the twig. Trace the rootles to their finest tips. How small, slender, and delicate they are! Still, we do not see the finest of them, for in taking the plant from the ground, we tore the most delicate away. In order to see the real construction of a root, we must grow one so that we may examine it uninjured. To do this, sprout some oats in a germinator or in any box in which one glass side has been arranged, and allow the oats to grow till they are 2 or more inches high. Now examine the roots, and you will see very fine hairs, similar to those shown in the accompanying figure, forming a fuzz over the surface of the root near the tips. This fuzz is made of small hairs standing so close together that there are often as many as 38,200 on a single square inch. Figure 17 shows how the roots look when it has been cut crosswise into what is known as a cross-section. The figure is much increased in size. You can see how the root hairs extend from the root in every direction. Figure 18 shows a single root hair, very greatly enlarged, with particles of sand sticking to it. These hairs are the feeding organs of the roots, and they are formed only near the tips of the finest roots. You see that the large, coarse roots that you are familiar with have nothing to do with the absorbing plant food from the soil. They serve merely to conduct the sap and nourishment from the root hairs to the tree. When you apply manure or other fertilizer to a tree, remember that it is far better to supply the fertilizer to the roots that are at some distance from the trunk, for such roots are the real feeders. The plant food in the manure soaks into the soil and immediately reaches the root hairs. You can understand this better by studying the distribution of the roots of an orchard tree, shown in figure 19. There you can see that the fine tips are found at a long distance from the main trunk. You can now readily see why it is that the plant usually wilts when they are transplanted. The fine, delicate root hairs are then broken off, and the plant can but poorly keep up with its food and water supply until new hairs have been formed. While these are forming, water has been evaporating from the leaves, and consequently the plant does not get enough moisture and therefore droops. Would you not conclude that it is very poor farming to till deeply any crop after the roots have extended between the rows far enough to be cut by the plow or cultivator? In cultivating between corn rows, for example, if you find that you are disturbing fine roots, may be sure that you are breaking off millions of root hairs from each plant, and hence are doing harm rather than good. Figure 20 shows how the roots from one corn row intertangle with those of another. You see at a glance how many of these roots would be destroyed by deep cultivation. Stirring the upper inch of soil when the plants are well grown is sufficient tillage and does no injury to the roots. A deep soil is much better than a shallow soil, as its depth makes it just so much easier for the roots to seek deep food. Figure 21 illustrates well how far down into the soil the alfalfa roots go. Exercise. Dig up the roots of several cultivated plants and weeds and compare them. Do you find some that are fine or fibrous? Some fleshy, like the carrot? The dandelion is a good example of a taproot. Taproots are deep feeders. Examine very carefully the roots of a medium-sized corn plant. Sift the dirt away gently so as to loosen as few roots as possible. How do the roots compare in area with the part above the ground? Try to trace a single root of the corn plant from the stalk to its very tip. How long are the roots of mature plants? Are they deep or shallow feeders? Germinate some oats or beans in a glass-sided box, as suggested, and observe the root hairs. Section 9. How the plant feeds from the soil. Plants receive their nourishment from two sources, from the air and from the soil. The soil food, or mineral food, dissolved in water must reach the plant through the root hairs, with which all plants are provided in great numbers. Each of these hairs may be compared to a finger reaching among the particles of earth for food and water. If we examine the root hairs ever so closely, we find no holes or openings in them. It is evident, then, that no solid particles can enter the root hairs, but that all food must pass into the root in solution. An experiment just here will help us to understand how a root feeds. Experiment. Secure a narrow glass tube like the one in figure 22. If you cannot get a tube, a narrow, straight lamp chimney will, with a little care, do nearly as well. From a bladder, make soft by soaking. Cut a piece large enough to cover the end of the tube or chimney and to hang over a little all around. Make the piece of bladder secure to the end of the tube by wrapping tightly with a waxed thread, as at B. Partly fill the tube with molasses, or it may be easier in case you use a narrow tube to fill it before attaching the bladder. Put the tube into a jar or bottle of water, so placed so that the level of the molasses inside and the water outside will be the same. Fasten the tube in this position and observe it frequently for 3 or 4 hours. At the end of the time, you should find that the molasses in the tube has risen above the level of the liquid outside. It may even overflow at the top. If you use the lamp chimney, the rise will not be so clearly seen, since a greater volume is required to fill the space in the chimney. This increase in the contents of the tube is due to the entrance of water from the outside. The water has passed through the thin bladder, or membrane, and has come to occupy space in the tube. There is also a passage the other way, but the molasses can pass through the bladder membrane so slowly that the passage is scarcely noticeable. There are no holes or openings in the membrane, but still there is a free passage of liquids in both directions, although the more heavily laden solution must move more slowly. A root hair acts in much the same way as the tube in our experiment, with the exception that it is so made as to allow certain substances to pass in only one direction, that is, toward the inside. The outside of the root hair is bathed in solutions rich in nourishment. The nourishment passes from the outside to the inside through the delicate membrane of the root hair. Thus does food enter the plant root. From the root hairs, foods are carried to the inside of the root. From this, you can see how important it is for a plant to have fine, loose soil for its roots. Also, how necessary is the water in the soil, since food can be used only when it is dissolved in water. This passage of liquids from one side of the membrane to another is called osmosis. It has many uses in the plant kingdom. We say a root takes nourishment by osmosis. Section 10. Root tubercles. Tubercle is a big word, but you ought to know how to pronounce it and what it means. We are going to tell you what a root tubercle is and something about its importance to agriculture. When you have learned this, we are sure you will want to examine some plants for yourself in order that you may see just what tubercles look like on a real root. Root tubercles do not form on all kinds of plants that farmers grow. They are formed only on those kinds that botanists call legumes. The clovers, cowpeas, vetches, soybeans, and alfalfa are all legumes. The tubercles are little knotty, wart-like growths on the roots of the plant just named. These tubercles are caused by tiny forms of life called, as you perhaps already know, bacteria or germs. The specimen at the right was grown in soil inoculated with soil from an old clover field. The one at the left was grown in soil not inoculated. Instead of living in nests in trees like birds, or in the ground like moles and worms, these tiny germs, less than 1/25,000th of an inch long, make their homes on the roots of legumes. Nestling snugly together, they live, grow, and multiply in their sunless homes. Through their activity, the soil is enriched by the addition of much nitrogen from the air. They are the good fairies of the farmer, and no magician's wand ever blessed a land so much as these invisible folk bless the land that they live in. Just as bees gather honey from the flowers and carry it to the hives, where they prepare for their own future use and for the use of others, so do these root tubercles gather nitrogen from the air and fix it in their root homes, where it can be used by other crops. In the earlier pages of this book, you were told something about the food of plants. One of the main elements of plant food, perhaps you remember, is nitrogen. Just as soon as the roots of the leguminous plants begin to push down into the soil, the bacteria or germs that make the tubercles begin to build their homes on the roots. And in so doing, they add nitrogen to the soil. You now see the importance of growing such crops as peas and clover on your land. For by their tubercles you can constantly add plant food to the soil. Now this much needed nitrogen is the most costly part of the fertilizers that farmers buy every year. If every farmer then would grow their tubercle-bearing crops, he would rapidly add to the richness of his land and at the same time escape the necessity of buying so much expensive fertilizer. Experiment. Take a spade or shovel and dig carefully around the roots of a cowpea and a clover plant. Loosen the earth thoroughly and then pull the plants up, being careful not to break off any of the roots. Now wash the roots, and after they become dry, count the nodules or tubercles on them. Observe the difference in size. How are they arranged? Do all leguminous plants have equal numbers of nodules? How do these nodules help the farmer? Section 11. The rotation of crops. Doubtless you know what is meant by rotation, for your teacher has explained to you already how the earth rotates or turns on its axis and revolves around the sun. When we speak of crop rotation, we mean not only that the same crop should not be planted on the same land for 2 successive years, but that crops should follow one another in a regular order. Many farmers do not follow a system of farming that involves a change of crops. In some parts of the country, the same fields are planted to corn or wheat or cotton year after year. This is not a good practice, and sooner or later will wear out the soil completely, because the soil elements that furnish the food of that constant crop are soon exhausted, and good crop production is no longer possible. Why is crop rotation so necessary? There are different kinds of plant foods in the soil. If any one of these is used up, the soil, of course, loses its power to feed the plants properly. Now each crop uses more of some of the different kinds of foods than others do, just as you like some kinds of foods better than others. But the crop cannot, as you can, learn to use the kinds of food it does not like. It must use the kind that nature fitted it to use. Not only do different crops feed upon different soil foods, but they use different quantities of these foods. Now, if a farmer plants the same crop in the same field each year, that crop soon uses up all of the available plant food that it likes. Hence, the soil can no longer properly nourish the crop that has been year by year robbing it. If that crop is to be successfully grown again on the land, the exhausted element must be restored. This can be done in 2 ways. First, by finding out what element has here been exhausted, and then by restoring this element by means either of commercial fertilizers or manure. Second, by planting on the land crops that feed on different food and that will allow or assist kind Mother Nature to repair her waste places. An illustration may help you to remember this fact. Nitrogen is, as already explained, one of the commonest plant foods. It may almost be called plant bread. The wheat crop uses up a good deal of nitrogen. Suppose a field were planted in wheat year after year. Most of the available nitrogen would be taken out of the soil after a while, and the new wheat crop, if planted on the field, would not get enough of its proper food to yield a paying harvest. This same land, however, that could not grow wheat could produce other crops that do not require so much nitrogen. For example, it could grow cowpeas. Cowpeas, aided by their root tubercles, are able to gather from the air a great part of the nitrogen needed for their growth. Thus, a good crop of peas can be obtained even if there is little available nitrogen in the soil. On the other hand, wheat and corn and cotton cannot use the free nitrogen of the air, and they suffer if there is an insufficient quantity present in the soil. Hence, the necessity of growing legumes to supply what is lacking. Let us now see how easily plant foods may be saved by their rotation of crops. If you sow wheat in the autumn, it is ready to be harvested in time for planting cowpeas. Plow or disc the wheat stubble and sow the same fields to cowpeas. If the wheat crop has exhausted the greater part of the nitrogen of the soil, it makes no difference to the cowpea, for the cowpea will get its nitrogen from the air and not only provide for its own growth, but will leave quantities of nitrogen in the queer nodules of its roots for the crops coming after it in the rotation. If corn can be planted, there should be a rotation in just the same way. The corn plant, a summer grower of course, uses a certain portion of the plant food stored in the soil. In order that the crop follow the corn may feed on what the corn did not use, this crop should be one that requires a somewhat different food. Moreover, it should be one that fits in well with the corn so as to make a winter crop. We find just such a crop in clover or wheat. Like the cowpea, all the varieties of clover have on their roots tubercles that add the important elements of nitrogen to the soil. From these facts, is it not clear that if you wish to improve your land quickly and keep it always fruitful, you must practice crop rotation? An illustration of crop rotation. Here are two systems of crop rotation as practiced at one or more agricultural experiment stations. Each furnishes an ideal plant for keeping up land.
First year, summer, corn, winter, crimson clover. Second year, summer, cotton, winter, wheat. Third year, summer, cowpeas, winter, rye for pasture. Or, first year, summer, corn, winter, wheat. Second year, summer, clover and grass, winter, clover and grass. Third year, summer, grass, winter, grass for pasture or meadow.
In these rotations, the cowpeas and clovers are nitrogen-gathering crops. They not only furnish hay, but they enrich the soil. The wheat, corn, and cotton are money crops, but in addition, they are cultivated crops. Hence, they improve the physical condition of the soil and give opportunity to kill weeds. The grasses and the clovers, of course, used for pasturage and hay. This is only a suggested rotation. Work out one that will meet your home need. Exercise. Let the pupils each present a system of rotation that includes the crops raised at home. The system presented should, as nearly as possible, meet the following requirements. 1. Legumes for gathering nitrogen. 2. Money crops for cash income. 3. Cultivated crops for tillage and weed destruction. 4. Food crops for feeding livestock. End of Chapter 2.